Hey everybody, this is Larry. This is June 25th of the 25th day of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join the Discord, hang out, do everything. Find a duplicate number. Given an array nums containing n plus 1 integers where each integer is between 1 and n, inclusive. Prove that at least one duplicate number must exist. Assuming that there only one duplicate number, find the duplicate one. I mean, this is silly. Okay, fine. I mean, the proof is basically just pigeonhole principle. If you want to read up on the pigeonhole principle, just Google it. But it's literally just called. Let me just write it out so that you can maybe see it and then Google later. Principle, pal, no. And then find a duplicate one. Yeah, so the short answer to this problem, and some of this is because I have seen versions of this problem before. The thing to kind of pay attention to this problem is the 1 to n inclusive part, because from that, there's a formula, in fact, to calculate the sum of all numbers between 1 to n, and then from that you could do the sum and then figure out what the n plus 1 number that way is. So we can actually figure that out pretty quickly. So now let's just say the sum of the numbers is, or total is equal to sum of nums, and then we just return the total minus whatever formula that we have for the nums, and it is just n times n plus 1 over 2, where n is equal to length of nums. And that should be it, though maybe I'm off by 1 because I always have off by 1 situations. But do I have 1 1? Okay. Oh, is this minus 1 because we don't count 0? Is that why? But yeah, so that's pretty much the problem. Yeah, is there anything to talk about it? I mean, let's just submit. I think it's oh man, oh, did I misread this one? Okay, so this gets a little bit interesting then. That's I think I okay, I think I just misunderstood this as another problem. So this actually is a little bit more interesting. So, but I would just as a caveat, if this was the problem where every number is unique except for 1, which I guess I just read into it like that, then that's how you would do it. But okay, cool. Let's think about it again then. Given that the number, so you cannot modify the array, so you can't even do sorting. The complexity should be less than O of n squared. There is only one duplicate number in the array, but it could be repeated more than once. Okay, so I guess if I had read the constraints, I could have done that. Okay. So we can do better than so we can do worse than O of n, but it has to be less than n squared. So we can probably do a binary search. So the recurrence we would ask ourselves with the binary search in this case is that I guess I really didn't read it. With the binary search, you can count how many numbers are. I guess it doesn't matter in which direction, either smaller than it or bigger than it. I could just, doesn't matter which way. And then from that, you can do more pigeonhole principle to figure out which side it is on, and then whatever side it is on, you pick the side that, and then from that you're able to figure out what the number is from binary search. Okay, so yeah, whoopsie daisies, but the pigeonhole principle part is still true though. But yeah, so head is equal to 0, tail is equal to n, where n is so nums is the n plus 1, so n is actually equal to the length of nums minus 1 technically. No. I'm just trying to think a little bit about the edge cases, but let's try with n, because each number is between 1 to n, so I think that'll be okay. Yeah. But maybe we could do a ternary. Maybe that's more reasonable to understand. But do we have a binary search? Let me think about it for a second. I think it's a variation of what I said, but let's say, for example, you look 3 and 1, 2, and 3 has 4 elements, so it must be in there. Yeah, okay. But if it's... Yeah, no, I think this is okay. Okay. So now just regular binary search stuff, mid is equal to head. I wonder if I did like wrong last time too, but yeah, if I just say if I just call it good of mid, and good means that there are mid number of mids in the count, because if it's more than it, then that means that is into it. Okay, so actually let's just pass this for now. So I could write the good function. So the good for this case for a given x is that there are less than x elements. Oh, sorry. There are exactly x elements of x or fewer. Because if it's fewer, then you know that on the other side. I mean, so there could be more. Yeah, there could be. Oh, assuming that there's only one duplicate. Okay, so given that this assumption, because if there are multiple duplicates, I guess it doesn't really matter. But given that there's only one duplicate, then this, if you count for a given number x, it will only give you either x elements or x plus 1 elements. So that's what we have to count for. So yeah, so count 0, 0. So for y in nums, or num in nums, I guess we could actually just return length of y for num in nums if num is greater than x, something like that. And I'll just write it out so that's easy to understand. So if num is less than or equal to x, we increment count. Otherwise, I mean, there's no otherwise, just return the c. We return whether, okay, if this is exactly x, I'm just gonna write it this way, because if it's bigger than x, that means that there is a duplicate number. Yeah. Okay. Let's rename this to isDup. Okay. So if there's a duplicate, then we want to move the tail to mid. If there isn't a duplicate, then that means that we need more numbers, so you move the head to at least the mid plus 1. So okay, so then now we just return head. I think that's okay. They got me with the inputs though, because they didn't even try to like be a little bit fancy about it. I got wrong answers here though, but I'm a little sad about that. But maybe I got my sides wrong. So isDup. Oh no, yeah, I used the right name here, but I did it this other way. So there's a dupe if it's greater than x. So I just have to fix that. Okay, and then now submit again. Okay, cool. Yeah, so I just misread the problem, and this happens actually in contests/interviews as well. So if that's the case, make sure you're talking with your interviewer or just double check. I definitely solved this one too fast, and there are contests where that happens because I was just solving it too fast, and I just misread it. But yeah, so what is the complexity for this algorithm? This complexity is n log n. And you can see why this is n log n, because, well, this loop happens over log n time because every time it halves itself. And then this loop, and every time, every iteration of this loop, it does this, it makes the call to its dupe, which is O of n times. And you can kind of also see why, because it's this goes through. And in total, this is n log n, the space complexity O of 1. For both interview and competitive programming, I definitely recommend it. Binary search, if you watch the stream at any given time, and I have been doing all the June, May, and April Leetcode daily challenges, so hit the subscribe button for that. But that I say binary search happens a lot, so definitely practice it and be comfortable with it. And yeah, and to kind of make it reiterate, so kind of to have a little bit more focus on why this is the case. So if this duplicate, so the invariant for a binary search is that once something becomes true or false, it doesn't really matter because you just do a not function to it, then everything after that is true or just continues to be. And the thing to notice is that there's only one duplicate number. So because there's only one duplicate number, for every given number, well, you know that if there's 1 to n, then, or if there's n plus 1 numbers, then one of them has to be duplicate, right? So this is always true for n. And then there's some, and then you could go the other way where, okay, so you can actually visualize it a little bit if you just generate an array, which is that, okay, let's say this is the array and there's no duplicate numbers yet, but there's only one number smaller than 1 after you sort it. I mean, we don't sort it in this case, but let's say you sort it. There's only one number smaller than 1. There's 2 numbers smaller than 2. There's 3 numbers smaller, or sorry, 3 number that is the number 3 or smaller. 4 numbers that's 4 numbers that's 4 or smaller, and so forth. Dot dot dot. Right? But let's say now we add in a duplicate number, right? Let's say we add in the number 4. Well, one number still, again, one number is 1 or smaller, 2 numbers 2 dot dot dot, or to 4, where it becomes, well, 5. There's x plus 1 number smaller than or equal to 4, right? And here again, there's 6 number that's 1 or sorry, that's 5 or smaller. There's 7 numbers that's 6 or smaller, and so forth. So that's the transition between the isDupe function. That's how we calculate this. And for the binary search, again, usually I make it more visualization, but then I got a little bit lazy, I guess, which is that, yeah, if let's say we look at 5, right? Well, in this case, we know that there is a duplicate number that's 5 or less. So we know that we don't have to look at the right side, because we know that 5, or that the answer is either 5 or 4 or 3 or 2 or 1 for the smallest duplicate number, right? Because basically another thing to notice is that given what we said about this, the number of count is greater than x ratio invariant as we go from left to right, the first number that this is true for is the number, right? Like, because, and you could kind of figure it out yourself a little bit by using English, which is that 4 is the smallest number that has the first number that is more greater than itself, right? So, going from 3, you have 3 numbers that itself are smaller, and then here you have 5 number, which is, it jumps, right? So because of that, when you check whether 5, well 5, it has 6 numbers as itself or smaller, so you know that is not on the right side because all these numbers will have bigger numbers, right? So you throw it away. And then now you look at, say, now number 3. Well, the number 3 only has 3 numbers that is itself or equal, so that means that there's no duplicates. So that means that the right answer has to be to the right. So then you move the head to this plus 1 because you throw these away. Yeah, and that's kind of the idea that I took to kind of derive this pretty quickly. And yeah, that's all the things I have for this problem. Hope the visualization helps. Hope this is a pretty straightforward binary search question if you're able to come up with the relationship, the invariant, that given a number n and a size and you just count the number of numbers that are smaller than that number. Yeah, and given that there's only one duplicate number, all these invariants will be true. Yeah, that's all for this problem. Hope you enjoy it. Hit the like button, hit the subscribe button, join the Discord and hang out, and I will see y'all tomorrow. Bye bye.